Welcome to this tutorial on NumPy Trigonometry. Today we'll explore the np.tan function, which allows us to calculate tangent values element-wise for arrays and scalars in NumPy. Before we dive into the NumPy function, let's understand what tangent means. The tangent of an angle is the ratio of the opposite side to the adjacent side in a right triangle. Mathematically, tangent of theta equals opposite divided by adjacent. This can also be expressed as tangent of theta equals sine of theta divided by cosine of theta. The syntax for the np.tan function is straightforward. You simply write nump.tan, passing in x as the parameter. This function computes the tangent of each element in the input array, where angles are given in radians. The function takes one parameter called x, which is of type array_like. This means x can be a scalar value, a Python list, or a NumPy array containing angle values in radians. The function will process each element and return the corresponding tangent values. Let's look at a basic example. First, we import NumPy as np, then we define an angle as np.pi divided by 4, which represents 45 degrees. We pass this angle to np.tan and store the result. When we print the result, we get 1.0, which is the tangent of 45 degrees. The real power of np.tan comes when working with arrays. Here we create an array of multiple angles: 0, pi divided by 4, pi divided by 3, and pi divided by 2. We pass this entire array to np.tan, and it computes the tangent for each element. The output shows 0 for 0 radians, 1 for pi over 4, approximately 1.732 for pi over 3, and a very large number for pi over 2, since tangent approaches infinity at that point. There are three important things to remember when using np.tan. First, input angles must be in radians, not degrees. If you have angles in degrees, you'll need to convert them first. Second, tangent is undefined at pi over 2, 3 pi over 2, and similar values. At these points, the function returns very large values instead of infinity. Third, the function works element-wise on arrays of any dimension, making it perfect for vectorized operations. To summarize, np.tan computes tangent values element-wise for arrays. It returns the ratio of sine to cosine for each angle. This function is essential for trigonometric calculations in scientific computing, making it a fundamental tool in your NumPy toolkit. Thank you for watching, and happy coding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.